back to another discrete math tutorial. Today I just briefly wanted to cover bits and bit operations. So what is a bit? A bit is a binary digit that can be either 0 or 1. Bits may be used to represent truth values. Obviously 1 would be true, 0 would be false. Bits and bit operations are used in Boolean algebra. And Boolean algebra is like ordinary algebra except that variables stand for bits, and plus means or, and multiplication means and. Bits can also be part of bit strings. A bit string is written from left to right, and it would be something like 1 0 0 1 1 0 1 0 1 0. So that would constitute a bit string. Now, Boolean operations can be extended to operate on bit strings as well as single bits. So if we have something like the following bit strings, we can use Boolean operations to operate on the strings. So for example, we have a bitwise OR, we'll have a bitwise AND example, and we'll also have a bitwise XOR. So just like in the previous tutorials, this would signify OR and an exclusive OR. So let's go ahead and try to work out this bitwise OR, which follows the same principle as an OR. 1 or 0 is 1, since true or false would be true. 1 and 1 is 1, since true or true would be true in an inclusive OR. 1 or 0 is 1, 0 or 0 is 0, as false or false is false. 1 or 0 is 1, 1 or 1 is 1, 0 1 is 1, 1 or 1 is 1, 1 or 0 is 1, 0 or 1 is 1. In an AND, we'll have 0 or 1 is 0, 1 and 1 is 1, and then basically we'll just follow the same concept across everything else. So the only time an AND is true is if both values are true, and in a bitwise, if both values are 1. So this would be 0 0 0 1 0 1 0 0. In an exclusive OR, the only time, remember, an exclusive OR is true is if the values are opposite. 0 and 1 in a bitwise XOR would be 1, 1 and 1 would be 0, 1 and 0 would be 1, 0 and 0 would be 0, 1 0 1 0 1 1. And that's literally all there's to it. I hope you guys learned something new, and as always, make sure to subscribe for your daily discrete math tutorials.